Good evening, viewers. I'm taking the continuation class for yesterday. Up to yesterday, we covered this geometric mean, that is individual series, discrete series, and continuous series. Now, I'm going for the last measure of central tendency, that is nothing but harmonic mean. When you go for harmonic mean, we have to take into account the reciprocal. For geometric mean, we are taking into account the product of nth root of product of n items. But here we'll go for reciprocal. So what is reciprocal? 1 by any value is nothing but the reciprocal. 1 by any value. When you take 1 by 2, it is nothing but reciprocal. And the answer you'll come across in decimals. 1 by 2 is equal to 0.5. 1 by 3 is equal to 0.3333 recurring. 1 by 4 is equal to 0.25. Like that, you'll come across the reciprocal. Reciprocal means 1 by, 1 by any value is nothing but the reciprocal. Okay. Sir, we have taken into account the arithmetic mean, geometric mean, and harmonic mean. You told that they are nothing but the calculated averages. Whereas median and mode, they are nothing but the positional averages. And when you go for arithmetic mean, you have taken the addition of all the values, sum of observations by number of observations. When you go for geometric mean, you are taking into account the product and you are seeing the nth root of the product. Now we are going for reciprocal. Is this correct? Yes, this is also correct. Okay, this way also we can represent a representative value or whole value. So in this also harmonic mean also we will come across individual series, discrete series, and continuous series. When you go for discrete individual series, the formula is HM, that is harmonic mean, is equal to n by 1 n by, that is number of items, by sigma 1 by x. I told you that 1 by any value is nothing but the reciprocal. So in individual series, the harmonic mean value is, to calculate the harmonic mean value formula is n by sigma 1 by x. That is nothing but the formula for harmonic mean in individual series. When you go for discrete series, HM is equal to n by sigma f by x. That is, here we will come across the frequencies. So we have to take into account the individual frequency and we have to divide with the variable. So it will become f by x, and we have to add the f by x. Thereby you will come across sigma f by x. N is equal to, you can take that as n number of items or summation of frequencies. So HM is equal to n by sigma f by x. That is nothing but the formula to calculate harmonic mean, and through this harmonic mean also we can represent the value that was there in the variables or the given data. Now continuous series. Here in continuous series we have to take into account the mid values. Okay, how we will get the mid values? A lower limit plus upper limit by 2 is nothing but mid values. Okay, and the formula is same, n by sigma f by m. That is, in continuous series we will come across class intervals. So from classes, we have to take into account the mid values, and we have to divide the individual frequencies, corresponding frequencies, with mid values, and you have to total that. Thereby you will get sigma f by m. So n is equal to, we know that it is sigma f or n. So HM is equal to n by sigma f by x. With this, the harmonic mean will be derived, And harmonic mean is also one important topic when we are going for measures of central tendency. Now, after completion of this measures of central tendency, we are going for the next important topic, that is nothing but measures of dispersion. So we from by measures of central tendency, we came to know the representative value, or the value which represents the complete data. That is, but here when we go for measures of dispersion, it will take into account the differences. Okay, you can say that you, okay, you can say that, sir, by taking into central value or the representative value, what is the use? We have to see, and we will see so many differences. As if you take your hand will have 5 fingers, and all the 5 fingers, they won't look like, they won't be alike. You will see some differences in your fingers. In the same way, when you take data, okay, you will come across some differences. How to measure the differences? How to measure the differences? That thing, this measures of measures of dispersion, it will take into account. Now, in this also, we'll have 5 methods. First one is range. Second one is quartile deviation or semi-interquartile range. Third one is mean deviation. And fourth one is standard deviation. And fifth one is Lorentz curve. These are the 5 methods to calculate the differences between one data to another data, one value to another value. What is the difference that is existing between one variable to another variable? That is most essential. It is not taking into account the representative value or whole value, please. We have to take into account the difference between one data to another data. This is most important. Now, coming to range, that is the first method in measures of dispersion. Range, it is nothing but the largest item minus smallest item. Range is equal to largest item and minus smallest item. When you are going for measures of dispersion, one thing you have to observe is you have to take into account two differences: absolute difference and relative difference. So, what is absolute difference and what is relative difference? Absolute difference means whatever it may be, the difference that we measure in the units given, units of measurement given, that is nothing but absolute dispersion or difference. And relative dispersion or relative difference is nothing but they won't take into account any units of measurement. They'll give the least difference that we come across. So that is the difference between absolute measure of difference and relative measure of difference. So both the things we have to calculate in this measures of dispersion. That is, we have to take into account the absolute measure of dispersion as well as relative measure of dispersion. Okay, now coming to the first method, range. Okay, what is the absolute dispersion, sir? L minus S is equal to absolute dispersion. And what is relative dispersion? Relative dispersion is also known as coefficient. So, coefficient of range is equal to L minus S by L plus S. That is largest item minus smallest item by largest item plus smallest item. By this we will come to know about the relative measure of dispersion or coefficient of range. Now, the next method is okay. quartile deviation or semi-interquartile range. Here we'll take into account the quartiles, whatever you have taken previously, that is other positional averages, in that we will come across these quartiles. So that quartiles we have to take here. So quartile deviation, it is represented by QD. Now what is the absolute measure of dispersion? QD is equal to Q3 minus Q1 by 2. That is nothing but the absolute measure. And what is the relative measure of dispersion or coefficient of dispersion? It is same as that of range. That's why it is known as semi-interquartile range. Okay. So coefficient of QD is equal to Q3 minus Q1 by Q3 plus Q1. That is difference between third quartile and first quartile by summation of third quartile and first quartile. This is about the formula to calculate quartile deviation. First of all, when you are going for quartile deviation, first of all you have to find out Q1 value as well as Q3 value. Whatever it may be the series that was given, whether you are given the individual series, discrete series or continuous series, compulsory you have to find out the Q1 value as well as Q3 value. Then only you can go for quartile deviation or coefficient of quartile deviation. And as I already told you that how to calculate Q1, how to calculate Q3 in individual series, discrete series and continuous series, in the same way you have to calculate. And after calculation of Q1, that is first quartile, and Q3, that is third quartile, you have to take into account the quartile deviation. Quartile deviation, once again I am repeating the formula. Quartile deviation is equal to Q3 minus Q1 by 2. That is absolute measure of dispersion. Now relative measure of dispersion or coefficient of quartile deviation is equal to Q3 minus Q1 by Q3 plus Q1. This is the coefficient of quartile deviation. That is, we are taking into account the difference between the third quarter and the first quarter divided by 2, because we are taking two quarters. And relative difference, we have to take into account the difference between the third quarter and first quarter divided by the summation of first and third quarters. This is how you have to find out the quartile deviation. All these formulas I am giving you, okay, for your remembrance, please. Okay, not for fun sake. I'm giving you for your calculation purposes. Okay, some people they don't know this. Without knowing this, some people they'll do the problems. But one thing you have to keep in your mind is, unless otherwise you don't have or you don't know the formulae, you cannot proceed in the subject statistics. Statistics means the formulas. So you must be very thorough with these formulas, and with the usage of the formulas only you can able to solve any problem. Okay, here in statistics, people will give importance what type of formula you have used, and what are the steps that you have written. Okay, forget about the answer. When your procedure and when your stepping is correct, automatically you will get the answer. So they will give importance for the formula and they will give importance for the steps, whatever you have written. Now after this we will go for mean deviation, and this thing I will continue in the next class. Until then, have a nice day and please subscribe to my channel. Thank you.